or how are you?
Fine, sir. I think 5 to 10 minutes they will start the session, sir.
Your session is always very very interesting and
No, sir.
very knowledgeable.
Post जेवा share చేయొద్దా PPT? Okay.
अपने चीनी कम डालो। हाँ तो मैडम एक तो बस ऐसे तो फैमिली करते हैं आपको जिससे नहीं नहीं ऐसा मैं रात आए थे काफी तो नहीं हो रहा है
Dear participants, good afternoon to everyone. So I welcome you all for the afternoon session. But due to some personal problems, so Dr. Kiran Kumar, Associate Professor, Department of Mechanical Engineering, NIT Warangal, is unable to deliver his lecture today. So we have the substitute to Dr. Kiran Kumar by Dr. V. Sivareddy sir, Professor of Mechanical Engineering. So he is going to deliver a lecture on renewable energy technologies for sustainable development. So thank you, sir, for accepting this request. So over to you, sir.
Okay, sir. Thank you, sir. Yes. I think once again, thanks to our organizing team. They are providing one more opportunity to share my experiences. Earlier condition, exegetic analysis of solar alone and solar aided thermal power. Majority of theoretical analysis I shared, theoretical and economical evolution. Coming to today's lecture, maximum I will share whatever the projects I did after my PhD, government funded projects, how the renewable energy intervention will help for sustainable development. I think this lecture purely is practical oriented, and majority of the projects, whatever I am showing, majority of the projects funded by ICAR, Indian Council of Agriculture Research, and DST, Solar Energy Research Initiative, and DST again, Science Engineering Research Board. So majority these three are the major funding, and one more funding agency is MNRE, Ministry of New Renewable Energy. Already myself, already first day itself I introduced myself. I'm certified energy auditor. You may utilize for your institutions for NACA gradation purpose. Already I did my PhD from IIT Delhi only. Later my research experience is principal scientist and in charge head at Sardar Patel Renewable Energy Research Institute. There I learned more and how we can develop the technology with the small interventions, how we can retrofit with the existing models. There I learned more. I think for my practical experience is base only Sardar Patel Renewable Energy Research Center only. Every time as a teacher, it's a common, we have to guide, mentor, and facilitate the student community. Is our major task. For this only all FDPs, we are mediators for the end users. That's all. End users, we have to guide, teach, mentorship we have to provide and facilitate. Facilitation means R&D facilities. Whatever the science we are teaching to the students, the application of science, for that application of science, we have to provide the facilities. Without facility, we can't apply the science. They will mug up and they will get the marks. In engineering, we are getting marks, there is no use. I am 90%, I have again 90%, but I am working, I am trying for bank manager's job. Really you are engineering 90% means you are very good student. What is the next year of getting trying bank manager job? You can try, you can develop, you enhance the entrepreneurship because really you understand the application of science and you tried the application of science. So for that purpose only we have to show the facilities, some facilities available in the institute. This internal combustion engine related and composite materials, especially solar. We have well established laboratories. we have. Why? Because remaining facilities is supporting regular curricular activities also. But solar only for incubation we established. Dehydration. These all already explained. And second point, mentorship. Yeah, whenever I am giving lecture means my first priority goes to the holistic development of the person. That is first priority. That's all. I am gaining knowledge. I will get a promotion and all secondary. But what you required, that right understanding is important. Right understanding, because right understanding on relations and physical facility, both. If you have right understanding of these two, your hormones in self, family, society is in good conditions. Otherwise, it's all disturbed condition. If you are working only on physical facility without right and understanding of relations, ultimately you are in disturbed mode, preconditioned mode, negative attitude. This all came to the picture. If you are right understanding your relation, physical facility, everything, mutual happiness and mutual prosperity you will get. For this, I will give one example. Earlier, last in 14th lecture also I mentioned. With the examples, we are explaining this right understanding to the student community. They may change their attitude. They may change their goals. At present, their goals on physical facility. I want to purchase car. I want to earn money, or I want to live luxuriously. That is at present student community target. But that is not the target. What is their target? How the give values to the relations? How what is the importance of the physical facility? How much time we have to spend for physical facility is important. For that reason only, this lecture I will give one small example. With that example, I will skip to the our main topic. I know two faculty in 2015 to 2020. In this 5 years journey, I noticed two faculty. Two are 1995. They started their careers. One from PhD from IISc. One two careers, 1992, the oldest careers, they started their careers. One faculty, two faculties have the skill child only, and but one faculty PhD from IISc, one faculty PhD from local. This local basis of generally management scholar knows. They will give importance to IITs and NITs. So this fellow one minute. Sorry for inconvenience. Okay. So one fellow is getting less importance in career wise. Another fellow is more importance and more money is earning. So he is concentrated on earning money only. He is given less time to family relations, child and family. Ultimately, when they came to the after completing of intermediate, this IIT fellows child tried engineering. This local doctorate fellow, less salary income fellow, son tried in medicine. But this local doctorate faculty is given 50% of time. Why? Because in the professional career, not getting that much of importance. So he will give uh, for physical facility is doing in diet direction is provided. Now this fellow the for physical facility, his daughter not at least not qualified IIT JEE, not qualified IIT JEE. Finally, for IIT JEE purpose also he spent more than 10 lakhs rupees for coaching and all. But he spent money, but he is not devoted time on relation. At present, now his daughter is studying engineering at KLU with a donation of 10 lakhs and per year 3 lakhs, total 22 lakhs payment seat indirectly in computer science. She is studying engineering. So you are now we are this polite guy is given the time to all right understanding and given time for relation and physical facility. In physical facility, whatever the money earned by the only physical facility concentrated faculty, whatever the money earned, total money is spent for child education only. But he is not stored anything. But the fellow is devoted time relation, his child intelligence is increased. In government institution, he got medical seat with free of cost, maybe 10,000 rupees fees. With the 10,000 rupees means total 60,000 rupees. One doctor is coming. So that doctor also will work as ethically. Why? Because with 60,000 rupees, I become a doctor means I also professional ethics I can maintain. So the one example I am giving. So both maintaining the time for relations and physical facility is important. By right understanding we are maintaining this, we will get very good output. This is one small example I given, but I am insisting the faculty community, you give right understanding to your not children's, your students. Then only holistic development of student will take place. That is important at present because we have enough number of engineers. They don't know the morals, ethics, values, and value for person also they don't know. That is important at present. So that purpose only I am giving this example. So okay, coming to our today's topic, sustainable development, sustainability and ethics. The ethics and sustainability is I think common word. Ethical, sustainable development by the ethical practice. General definition of sustainable development is development that meets the needs of present without compromising the ability of future generations. It's important. Whatever the development we are doing meets the needs of present without compromising, without disturbing, without compromising the ability of the future generation is called sustainable. Coming to the engineering ethic point of view, ethical practices require being considerate of the needs of future generation. This is important. Ethical practices are important. Since the world resources belongs to the next third one, green and sustainable practices means without inflicting irreversible damage to the environment and without disturbing the ecological balance, whatever the development we are doing is called sustainable. Three types of definitions. But what are the concerns? What are the concerns for the sustainable development? First concern, water pollution. The first concern for the sustainable development is water pollution. Next, solid waste disposal. Electronics revolution is taking place at present. What is the electronics waste? We are unable to recycle the electronic waste means the world is a dump yard of electronic instruments indirectly. So next, hazardous air pollutants, ambient air quality, and last one, stratospheric ozone depletion. For this stratospheric ozone depletion, For this, only mechanical engineers are responsible persons. No other engineer. Only mechanical engineers are responsible persons. For the comfort, for the human being comfort, we developed the technologies. It may be internal combustion engine, or it may be external combustion engine. It is producing NOx. And second one, refrigeration and air conditioning facility. This is also chlorofluorocarbons. They are damaging the ozone layer. But after 30 years, 40 years, we realized, yes, whatever the development we did, that is not sustainable development. It is damaging the environment. Now we changed, we are substituting, for internal combustion engines, we introduced the norms, NOx 0.001 ppm per some meter cube of pollutant is required, like that. And we are stop the use of chlorofluorocarbons, substitute R134A, R717, other refrigerants we introduced. But we spoiled the stratospheric ozone depletion is takes place. First, ambient atmospheric air. If atmospheric air, CO2, NOx, CH4, chlorofluorocarbons, creating the greenhouse effect. Once greenhouse effect came to the picture, what is the major drawback means? Earth temperature is increasing. Due to earth temperature, melting of the ice will take place. Once melting, the rate of melting of the ice is increased, automatically it will increase the sea level. Once sea level height is increasing, means availability of land is decreased. Already population increasing, availability of land is decreasing. Second, stratospheric ozone depletion, I already mentioned. Because of NOx, because of chlorofluorocarbons, we are depleting the ozone layer. Only mechanical engineering. Mechanical engineering given very good solution for electrical energy generation, or very good solution for human comfort, refrigeration and air conditioning. But our solutions are spoiling the environment, ecological system. It is spoiling due to ozone layer depletion. And potential solutions. Okay, I am using renewable energy, secondary point. Other, what are the potential solutions to the environmental problems? The first potential solution is recycling mandate. Next, process change and sectorial modification. It's important. Like automobile industry is there. Due to IC engines, we are producing pollution. In olden days, what happened in trees, side by roads, national highways, trees are available. The trees are absorbing CO2, so there is no issue. At present, due to the road windings, no tree available any highway. Why? Because every time 2 lanes are converted to 4 lanes, 4 lanes are converted to 6 lanes. So trees not available. Then the pollution is increasing. To address this one, sectorial modification proposed by the Indian government, by the policy making. What they, not Indian government, worldwide they took the policy. We introduced electrical vehicle instead of internal combustion engine. We introduced electrical vehicles. Charging of electrical vehicle by again electrical energy. It is coming from fossil fuel only, but from thermal power plants. Then thermal power plant. I want to establish any thermal power plant. 600 megawatt thermal power plant means at least 200 hectares of land forestation is required. Otherwise, we will not get the permission of thermal power plant. Thermal power plant, whatever the CO2 it is producing, total CO2 absorbed by the power plant area only. So forestation is a mandate that environmental norms is there. Forestation is required. So there we are reducing the pollution. So we are changing the sectorial modification, acceleration of forestation, application of carbon and our fuel taxes. Carbon tax already we introduced, but due to the economical slowdown, that is not effectively implemented. But introduced carbon credit system, material substitution. Please mute your systems, your microphones. Next, promoting public transport, changing lifestyles, increasing public awareness on energy related environmental problems, like I already mentioned. due to the power plants, how due to the refrigeration system, how the environment is spoiled. Next, increase education and training, no doubt. Next, policy interventions. Next, potential solutions to energy related environmental concerns. Why? Because by renewable energy or advancement of energy techniques. What are the advancement of energy techniques? Means energy conservation and increase the efficiency of energy utilization. Energy conservation in 1980s introduced energy auditing for pulp and paper industry, for chemical industries, for steel industries. Next, I think cement. Next, power plants. Energy audit is a mandate criteria. At least per year, 2 audit reports are required. And energy conservation measurements for enhancement of increase effective utilization. Next, application of co-generation and tri-generation. We already introduced co-generation, tri-generation, especially paper and pulp industry, steel industry. They are generating their power and they are generating their steam needs or refrigeration needs. If they are generating steam, that steam, if direct heat is required, they use it for the direct the steam. Otherwise, by using steam, vapor absorption system, they will run, they will get the cooling effect. Next, use of alternate energies from the farms and the sources for transport already we initiated. We are adding the alternate fuels, ethanol. At present, petrol with ethanol only petrol we are coming. 10% ethanol is common for petrol. Biodiesel. Some alternate fuels we introduced. Energy source switching from fossil fuel to the environmental, no doubt. Use of clean coal techniques. Earlier we are burning coal. Now what they are doing means in the coal mine itself they are doing gasification. They are producing carbon monoxide. That carbon monoxide directly they are supplying power plants. So whatever the carbon deposits are there, it is available in coal mine itself. Clean coal technology, one of the technology I mentioned. Use of energy storage. It is a major task. Why? Because by renewable energy, we are generating electrical, but that electrical energy where we want to use, unable to store the electrical energy. It is a big task at present. The thermochemical energy storage. Instead of that, one more area at present, one more research area, especially KS Reddy sir is doing in IIT Chennai and IISc Bangalore also they are doing some research. Instead of producing of electrical energy, you generate cracking of the water. If you crack the water, we will produce oxygen and hydrogen. So oxygen can use for hospitality purpose, hydrogen can use as a clean energy fuel. Hydrogen is burning means we will produce water only. So clean energy fuel, hydrogen we can produce by cracking of water by using solar concentrating technology. Once we produce hydrogen and oxygen means we can run effectively our system. There is no question of that. Next, this sustainabilities, you can see now whatever the sustainabilities I explained. When I will get holistic sustainable development means one is environmental sustainability. If you are not concentrated, it is a big issue. Even though we are getting all comforts, all energy sources, but we are not getting the holistic development. Next, energy. So energy and resource sustainability is a major. Our target for sustainability, we are first concentration we are doing energy, but my concern, my suggestion is concentrate on environment and social sustainability. You don't want to change the ecological conditions of the system. That is also one of the important things for all this economical sustainability. I developed extraordinary engine, but without our service engine, service engineer, our engine will not run means there is no use. Means economic sustainability will not come. Costly of operation is came to the picture. So social and environmental impact, technical aspects. Why? Because renewable energy point of view, I want to increase the sustainability by increasing utilization of the renewable energy means these are the concerns. If I overcome these 4 concerns, then there is no doubt in the future every part we can implement renewable energy technologies. What are the major considerations? Means social and environment is common. We have to consider this one. Technical aspects. Whatever the technology we are developing, that must be user friendly. User interference, easy user interference is required. Next, cost also. The major target cost. So one example I will give, solar PV plants. Everywhere we are constructing solar power plants. Any solar power plant, where everywhere we are constructing solar power plants, all are polycrystal panels only we are using. Why? Because you can cross verify. Light blue color or dark blue shade is coming. Polycrystal. The life is very low, and the power output efficiency, sustainability, study condition also not available. But we are using that polycrystal only, not using monocrystal PV cells. Monocrystal will give very good power output and consistency of power output also. After 5 years also, whatever the efficiency they promised, it will give after 5 years also. But polycrystal, after 5 years at least, degradation, at least 10 to 15% of the efficiency will degrade. But we are using polycrystal. Why? Because polycrystal PV cell cost is coming 15 rupees. Monocrystal cost is 45 rupees. Means investment, 3 times investment is changing. So economic factors main important. Next, commercialization. The strategies of commercialization is main important in renewable energy implementation. If we concentrate on these 4 points, then increase the utilization of renewable energy. If we increase the utilization of renewable energy, means automatically it will increase the our sustainability. I think with this introduction, now I'm moving to our main topic: renewable energy technologies for sustainable development. What are the technologies? Uh, what are the possible ways of implementation of renewable technology, and where I worked? Maximum I am sharing my work experience only, not other. Only I am sharing. The first one, an overview of solar energy utilization for dairy sector. My first project I took for dairy sector. I did energy audit for dairy. Then after, what are the energy flows, temperature of energy flow identified. Then how we can retrofit with renewable energy technologies with a cost effective manner. We proposed and we installed also. So small layout. First I will explain the dairy process. Then we came to know where our thermal utilities are coming. This is Vidya Dairy. It is a Amul Dairy R&D center. In Amul, all are knows at present. In Andhra also, it is Amul is introduced. In Amul, main plus point of Amul, they are doing R&D before introducing any new product. First, they will do R&D on one Vidya Dairy. Later, successful development of R&D output only, they will introduce the new product. Up to that, they will not introduce new product. And beauty is there. Remaining dairy is not like that. So this R&D center per day, they are processing. This is just R&D, means they are not doing R&D. General work, all dairy works they are doing. 1 lakh liters per day they are processing. For the process, they are collecting from local milk centers through the milk tankers. Tanker capacity may be 15,000 to 30,000 liters per trip. So maximum 1 lakh liters per day they are collecting in outside milk tank. What are the main condition? Means milk must be maintained 4 to 8 degrees. If it is crossed 8 degrees, means that Vidya Dairy will not allow the milk inside the plant. They will refuse. So it is less than 8 degrees, then only they will collect. After collecting, first they will chill the milk to 4 degrees. So chilled water is required for the maintenance of dairy industry. Next, they will do pasteurization. In the pasteurization, here pasteurization, we are killing the bacteria. How we are killing means we are sudden heating of the milk to 85 degrees and sudden cooling to 4 degrees. 85 to 4. Sudden heating and sudden cooling we are doing. This is called pasteurization. For this, we required hot water at 95 degrees, 90 to 95 degrees. But for this pasteurization, generally we are using steam only. Steam will condense in pasteurization tank. From that tank, hot water will distribute. Hot water is distributing the heat exchangers, plate heat exchangers. After reaching 4 degrees, the milk will stored in a milk tank. Each tank has the capacity of 30 liters. Milk tank is there. Total 2 milk tanks are available, 30 to 30, 60. Because at a time 1 lakh liters will not come into the picture. 2 shifts it will come. Maximum 50 liters it will come. So 60 liters storage tank capacity is there. So from this again it will go to the horizontal tank and it will go to the milk homogenizer or cheese section and ice cream section. Generally, here in Gujarat, they are not preparing paneer; they are preparing cheese. Means paneer compared to paneer demand, cheese demand is high. So in this R&D center, they are preparing cheese only. So 15,000 liters goes to the milk homogenizer. What is the need of homogenizer means for making tea. So for tea making purpose, homogenized milk we are taking. Next, cheese, 12,000 liters are moving to cheese and 2,400 liters for ice cream making. Remaining horizontal tank is there, 25 liters capacity horizontal tank is there. In this horizontal tank, it is going to the packing and distribution of the milk packets. This is the flow of milk. In every stage, the required heating or cooling means thermal requirements is there. For fulfilling that thermal requirement, you can see what are the sources. First, for cooling, we are giving chilled water tank, 10,000 liter capacity. 2 tanks are available, 5,000, 5,000. They're preparing by the chillers, by using chillers, we are preparing cold water less than 4 degrees. That water only we are circulating inside the dairy plant. Next, they are doing pasteurization. They are doing pasteurization. In pasteurization, the required 85 to 90 degrees, but 85 to 90 degrees purpose, they are using steam only. Next, sterilization is a canning. We are calling canning. It's with that purpose they are using 120 degrees temperature steam. Next, cheese vat for cheese vat purpose. Please mute. For cheese vat purpose, the requirement is 45 degrees. For that also they are using steam only. And spray drying, this is where we are using spray drying means by cheese way, cheese solid is separation. After separation of cheese solid, whatever the liquid is there, in liquid high protein matter is available. So separation of the high protein matter, they are doing drying. That is called cheese way. Amul Pro at present market is in market is available. Amul Pro, that is a dried portion of cheese whey, added some chocolate flavor, some other flavors. They are competitor of Horlicks or Complan, like that products. They introduced Amul Pro. For body grow, it is very much useful. Next, ghee preparation, 130 degrees of steam. Cleaning in the place, they are doing place cleaning, hot water 70 degrees, and crate washing, hot water 50 degrees. You see, majority of the temperatures are less than 100 degrees. Only sterilization and ghee preparation only we require high temperatures, remaining all low temperatures. Here, what we proposed, because total 1 lakh liter of milk we are processing is total 3 lakhs liters of wastewater is coming. 3 types wastewater is coming from the dairy industry. So for 3 lakhs liters of heating, for cleaning and crate washing, we proposed for cheese vat preparation, we proposed direct utilization of water, solar water heater. That solar water heater also not direct solar water heater, ETC with heat pipe water heater. By using that one, we will get 90 degrees, 80 to 90 degrees of temperature of hot water we can produce. And for pasteurization and sterilization ghee preparation, we suggested a shuffler dish system. Shuffler dish all are knows. Why? Because receiver is fixed condition. Main beauty of shuffler dish, I will explain on one R&D project we executed. Shuffler dish focal point is fixed. It is cut angle of parabola. Only receiver is moving. So not receiver is reflector is moving, receiver is fixed. So that directly we can connect the receiver stream to the pasteurization unit. It is easy to connect, and clean and green environment is producing. One shift operation we substitute by solar, pure solar, total solar. One is shuffler dish organization. Second one is ETC with heat pipe system. Why we concentration on dairy industry, and also first to my presentation itself I given dairy means a day-to-day life, dairy milk utilization is increasing drastically per capita. Capital invest consumption of milk is increasing drastically. It will not end. So high scope is available for utilization of renewable energy, and also milk food processing, clean and clean energy is required. Solar is the best clean and decentralized energy. That's why I shown this first application. I think please mute. I don't know who is in whose microphone is on. I don't know. Next, second one, reduction of hardness of the reverse osmosis RO rejected water for purpose of irrigation application. Sir, disconnect అయింది. చూడు ఒప్పింది రకం చెప్పుకుంటే ఎవరితో ఒకరిది ప్రాబ్లమ్స్ డిస్కనెక్ట్ అయిపోయింది కాబట్టి నా సరే So next, the RO wastewater. How we can process the RO wastewater? Why? Because all are knows the groundwater hardness is high, and that hardness is coming 300 to 500 ppm. But that is not drinkable. Generally, drinkable means less than 100. But at present, human being, their drinkable water means less than 20 ppm hardness, 20 to 30 only. We are using, all are using RO water because of that only. So while we are doing RO process, the wastewater hardness from 350 to it is increasing 500. 350 itself it is not useful for agriculture, means 500 it is not at all useful. It is a major issue for municipalities to handle this hard water. For this we proposed vibration with we introduced one vibrator. Through the vibrator, this hard water we are flowing the hard water. Once in the because of vibration, this hard water, because of this vibration, these hard particles, magnesium, chlorine, calcium particles are disturbing. This after creating of disturbance of these hard particles, we are using the permanent magnets to attract these hard particles. Automatically, we are reducing the hardness of the RO water. The RO wastewater, the hardness is 491 ppm before entering into the our vibrator, vibration effect and magnetic effect. After that, the hardness is reduced to 283, 252, 200, 232. So drastically less than 50%. 50% we reduced the hardness. How we reduce in simple way? We are creating vibration. Because of vibration, the hard particles are disturbing. After disturbance of the hard particles, we are attracting by the magnetic force. Just a small demo I am showing. Maybe by visualization of such the demo, we will get more awareness. You can see.
How many days it will be correct?
This is the vibrator. These are the permanent magnets. This pipe is magnetic pipe. After vibrator, we connected magnets. This wastewater we collected from our RO outlet pipe.
Sir, Satyanarayana sir, please unmute your phone. Mute your phone, sir. Satyanarayana sir, please. Sir, Satyanarayana sir, mute your phone, sir. Sir, hello, sir. Sir, sir, sure, sir.
చెప్పు అది వీడియోలో సౌండ్.
ఓకే సార్, అదే వాయిస్ రావడం లేదు సార్, అందుకనే సార్.
లేదు వీడియో.
ఓకే సార్, ఓకే సార్, ఓకే సార్, ఓకే సార్, ఓకే.
Is a 1 HP capacity vibrator. So small vibrator, 1 HP capacity, but every day we have to clean the permanent magnets. Then only we can effective attraction of the magnesium and calcium particulates is possible. Then we can reduce the hardness. Once it is less than 200 ppm means we can use for agriculture purpose, not for paddy. For paddy, less than 100 is required. So paddy purpose we can't use, but remaining paddy cultivation we can use that RO wastewater. Next, third one, solar drying is a major area. title I shown is a funding agency sponsored project. The journey of this dryer, I reached in this stage before I developed two models. I will explain the two and later I will explain. But what is solar drying? Next, first, what is drying? Purpose of drying. Drying means bringing the moisture, removing of the moisture from the any produce, any agriculture produce or any produce. How we are removing the moisture means we are removing the moisture. One is surface moisture, second one is bonded moisture. Above the surface, whatever the moisture is available, we are removing surface moisture. This surface moisture removal we can make by general open sun drying also we can make. That is not big thing. Or you left the product in outside in free ambient condition, the moisture we can remove. But removal of bonded moisture is the major target. What is the purpose of removing the long-term storage? I will explain long-term storage also. How we are removing means by capillary action, we are bringing that bonded moisture to the surface. Then removing the surface moisture. So that bringing bonded moisture to the surface, product to product it will change. For leafy product is other technique, for tomato is other technique, onion is other technique, or Ayurvedic techniques condition on that dryer. Purpose of dryer for long term storage facility. But where cap then material we are using drying. But what are the other methods in a next everything we are inside whatever things we are purchasing, our first target kept in fridge. That's all. Due to that also 40 to 60% of nutrient loss is taking place. Third one, industrial drying. Industrial dehydration will give very good drying opportunity. 5 to 15% of loss is taking place. Why? Because in industrial drying also we are heating the air maybe more than 200, 300 degrees by the combustion phenomena or by the electrical heaters we are heating. So it is reaching more temperature, automatically loss of nutrients will take place. But by the solar drying, majority of the loss will take place 3 to 5%. So we are introducing solar dryer. Solar means loss of nutrients. We are using solar drying. So it's more on solar drying. In solar drying, what we are doing by using solar collector, by using solar collector, I mean temperature. What is the purpose? 40, whatever. Now I am air temperature, automatically it is increasing the relative, it is decreasing the relative humidity of the air. If relative humidity is decreasing, what it will happen? More it is the capacity of air, absorption capacity of the air we are increasing. Automatically it will absorb more moisture from the product. So drying, two parameters we have to maintain in controlled manner. One is temperature, second one is relative humidity, maintaining the airflow. The third governing parameter is airflow. These three are main driving force for drying. You see, I measured the solar radiation, global solar radiation, in the month of 11th November. But because November, December, January, February, these 4 months only, we will get the all agriculture produce, onion, green chili, all we will get. At the time, cheap cost material is available. We are capable to dry, we can store. And whenever the rainy season is coming, at that time, we can utilize that products. But the intermediate nature, you see, drastic change is there. Solar radiation, there is no highly uncertainty is available in solar radiation. Next, coming to the next month, 12th month also, some 3 days we measured here also. Compared to this 1st January, somewhat better. Some graph we are capable to see. 5 o'clock only, because our college will open 10 o'clock up to 5 o'clock we are here also. Uncertainty is more. So this I think March somewhat good. Some March maximum for all products will exhausted. Utilization of all products will end. The product cost again will increase to abnormal condition. So there is no use. So wherever requirement is there, at the time of requirement, uncertainty of solar radiation is there. It means like opens and drying are not possible, not suit for. I will show the journey of solar dryers. The first one, household utilities purpose. Second one, purpose, the small commodity purpose. Third one, children. 3 stages I will show. All 3 stages, first stage only funded by our own funding. Next 2 stages are funded by, one is ICR, one is DST. This one small convection. We have to force convection means uniform drying of the product will take place. For this force drying purpose, small PV panel we selected, just a 15-watt panel, and 2 BLDC fans we connected. The 2 BLDC fans means nothing but that workstation system DC fans only. So solar is available, automatically fan will run. If solar radiation is increasing, automatically a solar PV output will increase, fan speed will increase, uniform temperature we can maintain, flow rate of the air will increase. And you can see after drying of this green leafy product, the color is not changed. The beauty of this dryer, any dryer, if color is not changing, means the nutrient condition, nutrient levels are maintained before drying and after drying. If color is changing, means melting of sugars is takes place, and the loss of nutrients and proteins is takes place. Only rupees, and explained our ex-CM in the expo. The second one, for catchment area, small catchments are there, small farmers, because India is mixing of small farmers. The small farmer in their catchment area itself, he is capable to dry his product means whenever demand is coming, at that time he can sold their product with a high price cost. For that, we developed one small dryer, PV integrated forced convection solar dryer. The beauty of dryer, this is a 2 meter square solar collector, 2 by 1 meter. Like this, 3 collectors are connected series. But 18% of the collector area, we stick with PV cells. In Gujarat, one of the main required industrial people are ready to support us. Glass, collector glass, they stick the PV cells. 18% of the area they stick the PV cells, and they again they return to me. and I connected to our collector. The PV cell output is connected to the blowers, DC blowers, and you see this collector drying area we placed backside of the solar collector. Why? Because to save the area, because at catchment area we are placing a separate dryer cabin means again it will consume more area. And second advantage of this loss of the dryer temperature dryer dryer, so we can achieve, you can see connected in series. Heating it is coming to the other dryer cabin. So we are effective utilization of the area is taking place. This is the total collector. Three collectors are connected. Loading capacity 50 to 100 kgs based on the surface condition of the materials. But drying capacity is 30 to 40 liters of the moisture it can remove per day. And the main advantage, once we fix the inside temperature early morning by the controller, then throughout day it is maintaining same temperature. Why? Because if solar radiation is increasing, automatically PV panel output is increasing. Once PV panel output is increasing means automatically fan speed will increase. If flow rate of air increasing means temperature will again came to the initial conditions. For measurement of solar radiation, we placed pyrometer on the surface of dryer itself. Then any dryer, universal dryer acceptance means we are capable to dry tomato, onion. Then the dryer is the one of the universal dryer we can call as 40 kgs of onion we dried 2.5 days. It took 8 hours per day. It converted into 2.7 kgs. Cost economics came to the picture. It is taking 3 years time for getting payback substitute of PNG. A substitute of electrical energy, it is taking only 2.2 years. But after development of this dryer, we got requests from Medicinal and Aromatic Plant Research Group. This is the ministry sponsored Medicinal and Aromatic Plant Research, Director of Medicinal and Aromatic Plant Research, Boriavi. We supplied this institute. After now also it is available at their catchment area, means around 8 years completed. After 8 years also our system is running. Why? Because maximum warranty guarantee we are giving solar system is 5 years only. After 8 years of system is running. From these group feedback, they again Gendu Foundation adopted our design, and Government of Ayurvedic Medicine Plant Gujarat adopted. At present, total 7 to 8 systems are utilizing same design from same supplier also. Steelec Industries supplied our design. It's one of the successful model, I think, in my developments. Then after, with this experiment experience, whatever the title I shown, this solar hot fluid generator based dryer, we approached funding agency. Here, 2 modifications I proposed. Why? Because earlier condition, if solar is high, what happened? We are increasing the air velocity, we are wasting of the energy, that's all. For reduction of temperature, I am increasing the velocity radiation. So to eliminate that wasting of the solar radiation, what we are doing means separate solar collector is separate. By ETC with heat pipe collector we proposed. By using that we can generate the hot fluid more than 100 or 150 degrees temperature. So we are storing that hot fluid at a storage tank. And in dryer also, I already mentioned drying free moisture and bonded moisture. Bringing of the bonded moisture to the surface, at that time relative humidity of air is not increased. So same hot air we can recycle. Earlier condition, there is no option of recycling of the energy. At the time of recycling of the air, we can store the energy at a storage tanks. Then we can enhance the drying time. By this proposal, earlier condition solar dryer is working 7 hours per day means at present solar dryer is capable to work at least 1 hour excess or 1.5 hour excess time. Solar dryer is capable to work because of this two retrofitting. By this two retrofitting, we can do industrial model. I will show this is a full-fledged industrial model. 5 collectors, 3.2 meter square area, ETC with heat pipe collectors. 5 collectors we connected, and this is the 500 liters thermal storage tank. These two are circulating pumps. Here I shown for recycling of the air. These are the dampers connected. This is inlet dampers. Means automatically recycling of the air is taking place. At the time of recycling, we will store the thermal energy. We are not circulating the hot fluid inside the dryer cabin. This is the dryer cabin. Dryer cabin because full-fledged interested to propose. This is the dryer cabin. Downside of the dryer cabin, we kept the radiators, 1.5 ton capacity radiators, 3 radiators. In these radiators, hot fluid will circulate by the blower, whatever the blower is there. Through the blower, hot air will circulate inside the entire dryer cabin. This is the total cyclic operation of the system. Collector, storage, air blow, recycling, and dryer cabin system. This system, after that, we run the system in the thermal oil field with dryer cabin utilization. The temperatures are coming 70 degrees. If direct storage of thermal oil is taking place, heat transfer fluid is taking place, it is reaching 130 degrees. If direct storage is 130 degrees, if we are using directly in dryer cabin, at the time also it is reaching 70 degrees. So inside the dryer cabin also, you can see from November to March, month-wise dryer cabin temperatures are shown 75 degrees, 65 degrees, 50 degrees, 45 degrees. Means according to requirements, I can change the temperatures. If suppose I want to dry the onion, I want to maintain 70 degrees. If I'm dry the tomato, also around 55 to 60 is required. I want to dry the green chili, 45 to 50 is sufficient. I want to dry the leafy products. 35 to 45 more than sufficient for the leafy products. So product to product, drying temperatures and moisture maintenance conditions, air moisture conditions are changing. So majority this dryer we can use for multi-purpose. So we dried onion with a single day drying is took place. 80 kgs of onion after drying, it came to 5.4 kgs. For slicing of the onion, we used onion slicer. These are the cost effectiveness. The total cost of the dryer is coming 5 lakhs rupees. The investment cost 5 lakhs rupees. Then after successful development of the item. One minute. Some power fluctuations is sure. This is cut portion of the parabolic dish. So main advantage, this receiver is fixed, reflector is moving. But major drawbacks, I will show this one. This schematic view you can easily understand. The parabola, this. So dual axis tracking is required. Shape change is required per day. Overall per year, 23.5 degrees of angle of rotation is required. For the north to south, east to west per hour, 15 degrees rotation is required. For this general tracking, timer-based tracking system is already available. For this shape out purpose, dual axis tracking is not there. They are using manual tracking system. Afternoon time, we are getting the beam radiation, point focus. Remaining day, it is not getting point focus. So required temperature is not reaching in receiver. Generally, shuffler dish, generally they are using for midday meals, for Shirdi or Tirupati. In all places, they are using midday meals purpose only. For that, not required. But for our industrial utilization, means entire day point focus is required for us. For that only, we proposed DST. We will introduce dual axis tracking. How we are introducing means this total linear activation, this length of activation, total 970 mm, means near 1 meter length. So we substituted by linear actuators, DC linear actuators. That motor rotation, motor speed, the per day movement, we are programmed by the controller. So every day early morning, just we are switch on the north-south controller. Automatically, it will do change the shape of the system. Automatically, we will get the point function. So every day morning, just 1 minute time is more than sufficient. So requirement of manpower drastically reduced. Next, receiver capacity enhancement also we took the by CFD analysis. We will enhance the receiver efficiency. With these two objectives, we took the project. We successfully enhanced. Later, the same system we installed in dairy and second in medical university also. Why? Because in Charutar Vidya Mandal under our group only one more medical institute is there. In that medical institute for sterilization of the that medical raw materials. For that, two systems, Karmasad, the name of the area is Karmasad. There we installed two shuffler dish systems and two at dairy industry we installed. Now they are successfully utilizing with these two modifications only. The project total project cost is 79 lakhs. Small modifications. Whenever we are approaching the funding agency, they expect two things. One is, what are the modifications you are proposing? That modifications within the due time is capable to execute or not. You are capable to execute, then what is the end use? That's all. These 3 points any funding agency concentrating. That's why whatever the modifications, whatever the retrofittings I am doing, very, very small things only I am selecting. I will not do entire from zero to sky is the limit, like that. The proposals we are giving is no one will accept. Small 2 modifications I can do within 2 years. Last year I will do demonstration and commercialization. That's all. This is my objectives of the project. At present, this developed system is available with the manufacturer. We transfer the technology to tailor-made solutions. Dharmendra Bhai is the, I think from Shuffler onwards, from scientist Shuffler onwards, he is in the shuffler dish field only. Now also is available in Ahmedabad. His head office in Ahmedabad. Next, a small modification. This one, northeast regions before 1990s for primary health centers for storage of the medicines, vaccines. Sperry developed the system, Sardar Patel Renewable Energy Research Center, with simple principle. Solar PV panels, 240 watt solar PV panels, and 2 batteries connected for storage of the solar energy. And they are running with please mute. So solar general AC solar refrigerator. So here AC to DC to AC converter they are connecting and they are running the fridge. This type of system cost is coming 1,38,000 rupees. This type of system they installed at different primary health centers, PHCs in northeast area in the supporting of ICR. But after I joined, instead of the electrical thermochemical storage, I can store the direct thermal energy like ice by using the, and I replaced the AC compressor with the DC compressor. So direct solar panel with direct solar panel, I can run the compressor. First advantage. So there is battery requirements is not required. Whatever the solar radiation is available at that time, entire 7 hours, my compressor will run and it will generate the ice. That ice will cool the vaccine cabin. This is our proposal, and we developed the system. But you see, pure water I selected as a thermal storage. This chamber temperatures, you see, chamber temperatures afternoon time it is reaching less greater than 10. Generally, 4 to 8 degrees temperature is required for vaccine, but it is crossing 10. So for that, what we did means 5% ethyl glycol we added. So addition of the 5% ethyl glycol, the condensation temperature is changed. So automatically the chamber temperatures are reduced less than 8 degrees. So later for supply of the customer, we further enhancement of ethyl glycol we did 10% of ethyl glycol we added. So further temperature drop is takes place in the full load condition. Also, my cabin temperatures will maintain less than 8 degrees. This is the proposal. The cost of the refrigerator now it is came to 60,000. With 50% cost, we are producing same effect. These systems again we distributed to some tribal areas of Gujarat. In primary health centers only. At present, it's running very well. A small modification. Next, one more proposal is that wastewater evaporation. All industries, I already mentioned, in dairy industry, 1 lakh liters of milk they are processing means 3 lakhs liters of water they are producing wastewater. 3 lakhs liters. That is the effect to R&D center output. In general dairy industry means more than 3 lakhs they will produce. So what we will do? Some of the chemical industry like paper, pulp, textile industry means in the wastewater, chemical recovery also required. For that, we proposed the system is humidification and dehumidification methodology. But for humidification demonstration project we developed. But for humidification demonstration project we developed. Here, one is air heater. Up to now in market, air heater means only rectangular 2 by 1 meter air heaters are available. For the rectangularness, cosine losses are more. Why? Because sun always not in opposite to, we can't maintain opposite to the sun. While sun is moving to east to west, automatically cosine losses are coming. Total solar energy we are unable to absorb. What that is the main drawback of air heater, general air heater. So we modified the air heater, rectangular air heater by circular air heater. This is one of our design target. Second, we developed the humidification chamber, effective humidification. Why? Because solar still, any type of solar still design calculation by the on the paper, theoretically we can evaporate 5 liters per day. Theoretically, practically maximum we are evaporating 2 to 3 liters per day. If effective still solar still designs are available, but in our development we excess what we are using means excess one air blower we are using. That's all. Section of air to the collector to the humidifier and small recirculating pumps we used. That is 30-watt recirculating pumps. These two are excess energy we are using, mechanical energy. Remaining all same. Now I will show. This is the new in-house air heater. You can see this glass tube from chemical industry, borosilicate gas only, 3 mm thickness borosilicate gas, 1.5 meter length market commercially available. Generally 2 meters means it is good, but in market only 1.5 meters are available. That's why we use that one. And aluminum sheet with a black coated aluminum sheet, circular tubes developed in-house only. Later, neoprene rubber cap. By using neoprene rubber cap, we are sealing of the insulation, means air insulation. This is not evacuated insulation system. By air insulation, creation of the air insulation, neoprene rubber caps we are connected, and this is the frame structure of the solar collector. So this is not evacuated air insulated tube, but in-house development. The overall heat loss coefficient per meter square Kelvin are evacuated means we will get 0.4, 0.6 only. But we have to import, and that much of not required also. For the purpose is different. This is the humidification chamber, you can see. So tubes inlet directly connected to the humidification chamber. These two are circulating pipes, pumps. This is the air blower. So air blower controller we connected. So according to need, the flow rate we can increase. This is the total system. So direct air heater, a pipe outlet is connected. So it's the air heater. This is the side view of the humidification chamber. You see the mass flow rate, evaporation rate liters per day, total area square collector. I am capable to evaporate more than 15 liters. It's an achievement. I already mentioned. Theoretically also we can achieve only 5 liters per meter square area, means 7.5 liters. But here we achieved double the evaporation in practical manner, not theoretical. How we achieved means, you see, air heater inlet temperature is 26 degrees, relative humidity is varying time to time, day to day, 46, 24, and specific humidity is 1. Air heater outlet, you can see, temperature is raised 10 to 15 degrees, temperature is raised, and relative humidity is reduced to 50% drop in relative humidity. Then last, chamber outlet, after humidification chamber, you see, 90% relative humidity. It is enhanced to 20 to 90%, means 70% of the moisture is absorbed per meter cube of volume of airflow. Because of this only we achieved 15 liters per 1.5 meter square area operation. With these results, we approached the funding agency. We are waiting for their comments. Once we got the funds, means dehumidification also, we will connect dehumidification, and we will check the water qualities also. What are the chemicals are recovered, or by this low temperature operating, means how we can separate that chemical, how we can reduce the waterness. Why? Because our target is municipal waste to drinkable water. That is our target. For that, initial steps we took. In future we'll see if we got the funds, means further research we will extend. I think in my entire career, one of the successful implemented project, development of solar hybrid refrigeration technology for on-farm safe transient storage of horticulture produce. Means we all knows what we are doing after harvesting. Suppose green chili we are harvesting, we are drying, or red chili we are drying, in open sun drying only they are doing. After that they are storing in at cold storage. Any produce we are storing at cold storage. So transportation loss from catchment area to cold storage. Why? Because cold storage are available at center, district center, or 3-4 districts combinedly one center. Cold storage are available. Everywhere cold storage are not available. So one transportation loss. Again, cold storage is not eating food. Again, we want to sell the product, means again it has to the near catchment areas also. Again, transportation loss. Next, third one, cold storage generally according to ASHRAE norms. The storage temperatures are defined based on not product quality, based on the cooling load. In what temperature very less cooling load is available, they will suggest, ASHRAE will suggest. Suppose tomato, 7 degrees temperature, effective cooling is less cooling load is available. Very good. So we are storing at 7 degrees. Once it came to the market temperature is 40. 7 to 40 degrees means it will face thermal shock. Simple logic. 7 to 40 degrees is coming means it is face thermal shocking. So due to thermal shocking, due to transportation, we are 30% of the agriculture product lost by double transportation and thermal shock. This one we highlighted and we proposed Indian Council of Agriculture. We will develop transient storage system at catchment area. Catchment area, we want to develop any cold storage means main problem grid connectivity. So grid independent cold storage facility. This is not cold storage, transient storage. Means we are not maintaining according to ASHRAE norms. We will maintain intermediate temperature, means ambient temperature is 40 means we will maintain 20 only, 15 to 20 degrees temperature we will store the product. So for this, how many days the product is available is how many days it can store, like the data is not available from the ASHRAE or anywhere product wise not available. All according to ASHRAE temperatures, yes, I store this temperature means the product life is 3 months, 4 months, 5 months, like that data is available. But this transient temperature data is not available in the universe, not only India. So for our first object, Anand Agriculture University, College of Food Processing Technology took the first object. What is that objective? At transient temperatures, I selected mangoes, different types of mango, Totapuri mango, Rajapuri, so many models are there. Each mango at transient temperature, what is the life of the mangoes? They will do laboratory test. So 15 days is the life of the mango means, yes, before came to the transient storage system, I will suggest the farmer, within 15 days you sold your goods in good condition. That's all. But this is for transient only, for not long-term storage. 15 days you sold, you plan your marketing structure. Or tomato, 15 to 20 degrees, it can store 1 month. Yes, we will suggest farmer 1 month you can store. So no transportation damage, no thermal shock damage will come into the picture. The main advantage to reduce the 30% loss of agriculture produce because of thermal storage loss and because of transportation. The second part, designing of grid independent cold storage facility. We took one Central Institute of Agriculture Engineering, Bhopal, CIE Bhopal, took the solar PV based cold storage facility. We took as a leader of the institute, leader of the project, we took this opportunity of solar hybrid, means solar thermal and hybrid. So more engineering component is there. That's why we took as a leader. Leader has to took more responsibility. And at the time, I'm head of the institute, head of the department. That's why I'm the PA of the project. So not because of me, I executed. Because of Sardar Patel Renewable Energy Institute only we executed. At that time, we are available. If Sivardi is not available, some other person can execute. Person is not do wonders. The institutions do wonders. We are the just carriers of the success rate of the institute. That's all. We are only the not persons. So refrigeration facility, we want to produce the refrigeration facility means simple logic. I will not take more time. Pressure and volume directly proportional to temperature. The specific volume is fixed. In the cycle, whatever the mediator I take, 3 liters means 3 liters is fixed. Meter cube per volume is meter cube per kg is fixed. Next, if pressure I am changing, temperature will change. I want to absorb the heat. I want to reduce the pressure, temperature will reduce, we will absorb the heat at evaporator. I want to reject the heat, so I want to achieve more than ambient temperature. Again, I am increasing the pressure. Automatically, temperature will increase. Above the ambient condition, automatically we will reject the heat. That's a simple logic of the refrigeration facility. This rising of the pressure, falling of the pressure, we can achieve by the throttling. But rising of the pressure, we can achieve by supply of the electrical energy is called vapor compression system. Supply of the heat is called vapor absorption system. That's all. Two difference. This is the basic principle of refrigeration and air conditioning. That's all. I want to raise the pressure by electrical energy is called vapor compression system. By heat is called vapor absorption system. This is the vapor compression system based system. This is implemented by the other group. Why we are not selected for that item is solar PV, solar radiation. I think every person knows about solar and infrared radiation, but this PV panels can convert only visible radiation. Means 43% of the solar radiation only we are capable to convert. Remaining 57% PV panels unable to convert. So wastage input to itself 50% input is lost by using a solar PV. Solar thermal means 100% of the thermal energy we can convert to the useful power. That's why we selected solar thermal system. I already mentioned lithium bromide water vapor absorption system. Here heat is supplying for rising of the pressure of the mediator. Here see here cooling this evaporator chiller also, chiller temperatures also we maintain 9 to 6 degrees. Why? Because room temperature I want to maintain 15 to 20 means chiller temperature 9 to 6 more than sufficient. Double the temperature scope is available. Next, hot water also in design we consider 82 to 88 degrees, less than 90. Same ETC with heat pipe system we can achieve this temperature. So theoretically, ideal COP we calculated based on the temperatures. We got 1%, 1 COP. COP is 1. For theoretically, if I use lithium bromide water, what is the COP we calculated? 70%, 0.7 COP. With this, we approached the Tata Group. They are ready to supply us. This is the VAM. This is a 5-ton refrigeration capacity VAM. At the time of fabrication, we visited the plant. We used this ETC. We used this ETC with heat pipe collectors. I already mentioned what is the purpose of ETC with heat pipe means. This heat pipe, this condenser unit, we are immersing in the manifold automatically. Water is flowing inside the manifold. Suppose one collector system is failed, our system is not, our process is not affecting. Maybe temperature rise will reduce, but leakage will not take place. Why? Because the water is flowing in manifold, not in tubes. That is one advantage. And effective transfer of heat from end point to the manifold is easy by the heat pump. With lower temperature difference also, effective heat transfer we can generate. This is the efficiencies. This is the 45 collectors we connected in 5 rows, 147 meters square area. The hot water temperature 80 to 90 degrees is designed, but luckily we got 90 to 95 degrees easily. Why? Because solar radiation estimations we did 600 watt per meter square on an average, but in this where we installed at Anand Agriculture University we installed, there the solar radiations more than 600. Why? Because in agriculture area means less polluted area. While solar radiation is coming, if more pollution is there, absorption of the radiation will take place. If less pollution means more solar radiation we will achieve. That's why we are achieving more solar radiation. We are achieving more temperatures. This is the P&I diagram of the system. This is the solar collectors, ETC with heat pipe collectors. Hot water storage tank is connected to the storage tank. Next, at the outlet of hot water tank, we connected biogas burner. Why? Because if solar is unavailable, Why? Because the system must be grid independent. If solar is not available, we will use biogas, bioenergy. Why? Because their cows are available. Cow dung based biogas plant we installed, 50 meter cube capacity, gas production capacity. I will show the plant also. And it is connected to VAM. VAM is connected to the VAM condenser is connected to the cooling tower. You see, VAM capacity is 5 tons. Our COP, theoretical COP, we got 0.7, but we are assuming practical COP will get only 0.5. Means 5 ton refrigeration effect we want to do. 50% efficiency means 10 tons of heating we have to supply. 10 plus 5, 15 tons. So 15 tons of the heat we have to reject at a condenser is important. That's why the cooling tower capacity is 15 tonner. Next, the chilled waters, 2 chilled water tanks we placed 1500 liters, 2 chilled water tanks. From chilled water tanks, it is connected to the dryer cabin, not dryer, sorry, cold chambers. It is connected to the cold chambers. You can see here hot water we selected only 1000 liters. Cold water we selected 1500, 3000 liters. What is the main purpose means cold water requirement was once product is harvested, at a time 2 tons, 3 tons of product is coming to the cold storage. At that time, sudden cooling is required. We can't run the VAM. After running of the VAM, we will produce the cooling effect. It is not right. Immediately we want to cool at that time. So ready availability of the chiller facility is required. That's why 3000 liters chiller facility we maintained. Second thing, heat loss also. Night time, suppose hot water I stored. Night time temperature 20, hot water temperature is 90, 70 degrees drop will take place. More heat loss also will take place. For that only, hot water for surge purpose only we kept the hot water tank, but chilled water for providing effective cooling in the cold room chambers. One more view of P&I diagram, visualization, picturization. This is the plant. You see in this also, I think here we are showing solar biogas refrigeration system for transient storage of agriculture produce. This is the P&I diagram. This is the hot water tank. This is the chilled water. This is the top view of the things. So this is the chilled water. This is hot water. This is the solar collector. This is the cooling tower. This is the biogas burner. And one biogas plant we connected. This is the modified Dinbandhu 50-meter cube biogas plant. 50-meter cube is not the volume is 50 meters. It will produce 50 meters of gas, meter cube of gas per day. It will produce by loading of 1 truck of cow dung, means almost 1 ton. 1 truck of cow dung input. It will produce 50-meter cube of gas. This is the actual picture of. This is the biogas plant. Cow dung and water inlet pipe mixing tank, and this is the slurry unit. Top side of the slurry unit, one shed we constructed for balloon purpose. Gas balloon we placed. Whatever the gas it is producing per day, it is producing 50-meter cube. So for storage of the gas, it is required for safety purpose. Why? Because Anand Agriculture University means education institute. Safety is first. That's why we constructed one shed for the balloon. This is the cow dung. Later you can see we are achieving the temperatures. The efficiency is nearer theoretical value we achieve, because theoretically the operated temperatures is 80, but here generated temperatures we are maintaining more than 90. That's why we reach the theoretical efficiencies. But again, I already mentioned grid independent system is for circulating pumps. Again, electrical energy required. For requirement of circulating pumps, electrical energy, small power plant, 10 kilowatt power plant we installed in the same plant, side by of solar thermal system. So now the entire system is grid independent. Thermal energy will produce by the biogas or solar thermal. For running of the circulating pumps, blowers, and VAM pump, we are using solar PV energy. So later, how much time is taking to cool the room to the 15 degrees temperature. You can see it is taking 75 degrees, 75 minutes time it is taking to cool the room. Then after first loading we did by Totapuri, I think. Totapuri, what? Rajapuri mango. First we did the test. Generally, two types of tests we are doing: physical property loss and chemical property. We did only physical property because physiological loss it is easy to measure the weight of the system by the physico-chemical process. The weight of the product will reduce day by day. How much weight loss is taking place? Next, firmness by testing itself, and spoilage by visualization we can measure. You can see physiological loss of weight in 5 days. If open atmosphere, we place 9% loss is there. In our transient storage system, not cold storage, transient storage system loss is 2%. Our second batch is 4.36% loss is there within 3 days. Here 0.65%. You can see the products. So this is now also, I think 2015 we completed. After 5 years also system is running successfully because university is maintaining very well. Dr. Sutar, he's at present he's a director, I think. At that time he's a senior professor, is one of the partner of our project. He is maintaining very well because 2017 we surrendered to Anand Agricultural University. 2017 onwards they are maintaining themselves. No way our role because project completed in 2015 itself. I think this one of the success project. Last one, this is heat recovery through canopus heat exchanger. This is theoretical proposal. Practically we tried, but cost effectiveness not came. That's why we dropped our proposal. But in your in and around area, any dairy industry is there. There you can implement. Why? Because there 50 ton or 100 ton or chillers are running. At that time we can implement. That's why I will explain that theoretical model. If any person interested to implement it, then you can implement. We published a paper also. You can search in Google. Dr. V. Sivardi, same title. You will get the paper also. Condenser, generally compressor outlet. Condenser temperature is generally 40 to 45 degrees. Their phase change is taking place, vapor to liquid. But once after compression, it will come into super critical condition. Means superheated condition, not critical. Superheated condition. 45 degrees is condenser temperature, means the vapors compressor exit vapors temperature more than 70 or 80 degrees it will come. At least 30 to 40 degrees difference is there. You are capable to extract that sensible heat. But because latent heat no use. 45 degrees ambient also available 40. That 5 degrees difference there is no use. But this 30 degrees temperature difference can be utilized for at least crate washing. Suppose dairy industry you are proposing, for crate washing is required 50 degrees only. You are capable to extract that 45 to 70 degrees of the sensible heat, automatically use that heat as a for crate washing purpose you can use, or some other purpose, or textile industry, some cloth cleaning you can use, or some hostels, or near hostels are there. They're in a hostel for cooking purpose you can use, or for bathing purpose we can use. But small capacity cost effectiveness is not coming. For large capacity we can achieve very good cost effectiveness, I think. With this I'm stopping my lecture. I think it is more than sufficient. If I am adding more, there is no use. With this, I am stopping. If you have any doubts, you can ask. Now I am hand over session to the organizers. Organizers.
So, dear participants, any queries? So I think the speaker explained from basics to development stage. So it is very useful session for the participants. So total systems explained. So what can we do with the solar? Any doubts?
Sir, participants, please kindly respond. Any doubts? Participants, please kindly respond.
Participants, please unmute yourself and ask any doubts, or you can interact with Professor Shivareddy. So no participant is asking the questions. So with this, we are going to conclude. So thank you, Professor Shivareddy sir, for giving the expert talk on the renewable energy. So thank you, sir.
Doubts are from sir, Siddharth sir. Sir, Shankar R. Doboji sir. Sir, the economic availability of vapor absorption refrigeration system, sir.
The economic viability of vapor absorption refrigeration system.
Yes, more than 30 tons capacity, 30 tons refrigeration capacity, vapor absorption systems are economically viable. Less than 30 tons it is not economically viable. 5 tons, 10 tons, 15 tons, 30 tons, more than 150.
Any doubts? I think no questions from the in the YouTube also. So we are going to close the session. So thank you, sir, Professor Shivareddy sir.
Okay, sir. Thank you very much, sir.
So dear participants, so with this today's session is over. So tomorrow we'll have the session by Narsimulu Sanke, Director, Center for Energy Technology. So he is a professor of mechanical engineering from Usmania University, Hyderabad. So he is going to give an expert talk on biomass energy. So thank you all for participating in the meeting.
সব বলছি వస్తుంది నాకు వచ్చి ఎగ్జామ్ కూడా ఉంది ఎగ్జామ్ సండే నాకు రూపాయలు
సపోర్ట్ చేస్తారు అంటే మళ్ళీ స్టార్ట్ చేస్తారు.
నాకు రూపాయలు సురేష్ సార్ బాబు సార్ రూపాయలు
సురేష్ గమ్మున అవుతుంది అంటే స్టార్ట్ చేస్తాను అన్నికి రాని చెప్తాను నేను సార్ గమ్మున అంటే నేను 2 బయటకు వెళ్ళినా